Hi everyone, I'm Sunung Moon from Pohang University of Science and Technology, and I will introduce our work titled Addressing Text Embedding Leakage in Diffusion-based Image Editing. As you know, text-to-image editing with diffusion models has made remarkable progress. However, when editing multiple objects simultaneously, the edits often spill over to unintended regions. For example, let's say we want to edit this source image and we want to turn the blue glove into a gold one and the box into a copper box. And existing baseline methods not only fail to edit the targets accurately, but also alter the background, producing undesired artifacts. We call this issue attribute leakage, and we categorize it into two types. The first type is target internal leakage, and this occurs when attributes leak between target objects. As shown in the highlight blue box, the copper attribute of the box spills into the glove, creating a copper glove. The second type is target external leakage. This occurs when unintended regions like background are edited. In the green box, you can see that even non-target objects and backgrounds are modified by editing prompt. However, our method A effectively prevents both types of attribute leakage. We found that the root cause of this leakage lies in the clip text encoder. Since clip encodes text autoregressively, the embeddings of layer tokens inherently entangle the meanings of earlier tokens. Moreover, the encoder attaches each prompt with multiple end-of-sequence tokens, and these EOS embeddings tend to entangle the attributes of the entire prompt. As a result, these entangled embeddings are passed into the cross-attention layers of diffusion models, causing the attribute leakage. This entanglement also leads to misaligned cross-attention maps. For instance, when editing yellow bell pepper to a red diamond and a red bell pepper to a golden apple, visualizing the cross-attention maps shows that activations don't align with the intended targets. Instead, the model focuses on the wrong regions, resulting in severe target internal leakage. Therefore, to eliminate this leakage, we must disentangle embeddings and align cross-attention maps. To address this, we propose attribute leakage-free editing called ALE, which consists of three key components: ORE, RGB-CAM, and BB. The first component, object-restricted embedding, separately encodes the prompt for each target object to produce multiple embeddings. For example, if the target objects are a diamond and the moon, we create one embedding for a diamond and another for the moon. And we also generate the base embedding for the background. And these object-specific multiple embeddings are used in region-guided blending for cross-attention map. Each embedding is applied only to its corresponding region, determined by segmentation masks, so that the cross-attention outputs are computed region-wise. And these segmentation masks are automatically generated by the grounded cell. This way, we can prevent cross-object interference. However, using these two modules alone is not enough to preserve the background. So, in the background blending stage, we blend the source latent and target latent based on the background mask. This ensures that only the edited regions use the target latent, while non-edited regions retain the source latent, effectively suppressing external leakage. Together, these components yield precise leakage-free edits without any additional training. To systematically evaluate attribute leakage, we also introduce ALE-Bench, a comprehensive benchmark with 3,000 editing scenarios. It includes 20 source images and 5 edit types and up to 3 target objects and 10 edit prompts. And you can see some examples here. And to quantify leakage, we propose two new metrics. The first one is target internal leakage score, and this measures interference among editing targets. And second one is target external leakage score, and this measures unintended background changes. As shown here, AIL achieves clear separation between edited and untouched regions, while baselines such as embedded and prompt still suffer from noticeable attribute leakage. In summary, we identify text embedding leakage as the core cause of attribute leakage, and we propose AIL with three key modules: ORE, RGBcam, and BB. And we also introduce AIL bench with two new metrics, TELS and TILS. And we achieve attribute leakage-free editing without any training. You can find more results and our open source code on our project page. Thank you for watching.